Bonjour, baddies. Welcome back to another video. Today's first question is, ABCD is a square. As you guys can see, I've already drawn out a square here. So A, B, that looks like a 3, C, D is a square. M and N are midpoints of A, B, and BC. So M and N, respectively. This is M, and this is N. What is the ratio of the area of MBN to the area of MDN? So MBN, so this triangle, to the area of MDN, so MDN, like so. So as you guys can see, a triangle's area, as you guys probably know, a triangle's area is equivalent to the height times the base divided by 2. As you guys can see in this triangle, in both triangles, they share the same base, which is this line. And if you look at that, and you guys can see that the only different thing that they now have is the height. So basically, if, let's just call this base, we can simplify by dividing top and bottom, blah, 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 and it's going to simplify off, so we only have the height, so it's just the ratio of the height comparison. And therefore, we only need to know the ratio of the height. Still sounds pretty difficult, right? Yeah, no. But there's another thing that can help you in this case. If we split this entire square down the center, you guys can see, since this is the line for the height for both of them combined, and as you guys can see, if we make a little here, we've split the height down the center, therefore this part is half of the entire height. And also, as you guys can see, if we just add a little thing here, splitting our entire square into fourths, you guys can see this is 1/2 and this is 1/2. And this means that the triangle, what did they say it was? Okay. Triangle MDN has 3/4 of their combined height. And triangle MBN has only 1/4 of their combined height. And we don't actually need to know what this height is. So it's 1/4 to 3/4, and if you multiply both sides by 4, it's just 1 to 3. So you don't actually need to know individually what the height is. We just need to know, the ratio. Moving on to problem number 2, a 30, 60, 90 triangle is drawn on the exterior of equilateral triangle ABC as shown, so that the hypotenuse of the right triangle is one side of the equilateral triangle. And the shorter side of the right triangle is 60 units, then what is AD? So this is the right triangle, right? And then this is 30 degrees, and this is 60 degrees. And it's asking what AD is, as the line is already marked. And if we know the formula for a 60, 30, 90 triangle, you know that if this side is 6, this side is 6 in the square root of 3, and this side is 6 times 2, which is 12. And using this, we can find out one side of the equilateral triangle. And if we think about it, now that we know this side, and since the equilateral triangle is equilateral, this side is also equivalent to this side, we can use the Pythagorean theorem again to solve for AD, since this is also a 90-degree triangle. And using the Pythagorean theorem and pulling out a 6 for both of them, we'll find that this is equivalent to 2 now. This is equivalent to square root of 3, and we can just multiply that 6 back on later on. And since the square root of 2 plus the square root of 3 is just equivalent to 3, and then we have to square root that, we'll get, since 4 plus 3 is 7, so it's the square root of 7, and then we multiply our 6 back on, in which we'll then get 6 square root of 7. So I'm just going to write it down nice and big. 6 square root of 7 is our answer. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new, and I will see you all on the next one. Bye-bye.